Allow me to introduce myself. I'm Chris Reed, manager at Credex LLC, a Tyler exploration production firm. I'd like to present my Chalybeate Prospect to you, a conventional shallow oil prospect from the Sub Clarksville, Pettet, and Rodessa. The Chalybeate Prospect is located in northeastern Wood County at the borders of the adjacent Franklin, Camp, and Upshur Counties. The prospect offsets Sub Clarksville oil production at the Shiner Pond field, found in 1990 at a depth of 4,200 feet and adjacent to and between Rodessa and Pettet oil production above a depth of 8,800 feet. The Chalybeate Prospect, pronounced Chalybeate, derived from the Greek word for iron-rich spring, is located in northeastern corner of Wood County, Texas, close to the abandoned resort spa ghost town of the same name, circa 1882. It is 6 miles due east of Winsboro townsite on Highway 11, midway to Newsom, Texas. The Chalybeate Prospect is within the prolific deep salt basin trend of the East Texas Mesozoic Embayment. It is a long trend and adjacent to prolific shallow oil production to the east and west from the upper Cretaceous Sub Clarksville Member of the Eagleford Group at 4,200 foot and the lower Cretaceous Rodessa and Pettet formations at 8,800 foot with potential reserves in excess of 4.58 million barrels of oil. Detailed subsurface and 80 miles of 2D seismic analysis establish the position of the trapping fault as well as the structural relief and closure at the primary objectives. The Sub Clarksville structure covers 300 acres, estimated to be 85 foot above the present oil-water contact of 3,700 foot at the Shiner Pond field. Rodessa Pettet closure is 550 acres with over 250 feet of structural relief above the production-tested oil. The initial Sub Clarksville and Rodessa Pettet test wells will be on a turnkey basis for both drilling and completion by an operator with lease operations on both sides of the prospect at Newsom, Pittsburg, McCrary, Marydale, Paul fields, and over 40 years of experience in the immediate area. Overall project finding lifting costs of 28 wells is $4.50 per barrel of oil with a 12-to-1 return on investment. This is an executive reference map showing the relative positions offsetting Shiner Pond field producing from the Sub Clarksville, found in 1990, the Newsom and Pittsburg fields to the northeast producing from the Sub Clarksville and Pettet since 1953 and 1940 respectively, the Winsboro and McCrary fields a long trend to the southwest producing from the Sub Clarksville field and Travis Peak from 1944. This is a tabulation of offset production with depth and direction. In summary, Newsom has produced over 4.4 million barrels, Pittsburg 20.26 million barrels, McCrary 2.2 million barrels, Winsboro at 4.15 million barrels. Adjacent average recoveries per objective horizon per well and average area of drainage indicate the Sub Clarksville with 120,000 barrels of oil per well, draining 20 acres. The Rodessa Lloyd Member with 150,000 barrels of oil per well, draining 40 acres. The Pettet Pittsburg Sand produces 360,000 barrels of oil per well, draining over 40 acres. This is a dip trending to line north-south, 2D seismic line crossing regionally faulted salt roller with key wells from the salt to the surface tied in. The salt accumulation in the light green on top of the rifted basement, thickest in the lows and thin to absent across the highs. The red fault on the salt growth demonstrating trapping conditions at the Rodessa in blue and at the Sub Clarksville interval at Shiner Pond field shown in red with 170 foot of displacement and documented in the subsurface at 3 separate points in the immediate area. This is a montage on the basin Austin structure showing adjacent production from Pittsburg Newsom to Winsboro McCrary fields with the reservoir conditions at the Shiner Pond field. The trapping fault plane map along with the life decline history at the Shiner Pond field is shown in the inset. We're looking at a first look seismic on the basin Austin. Our exploration method requires that if it doesn't show up in raw seismic, we don't have a project. This is a structural cross-section at Shiner Pond field with production curves. Original oil water contact in the discovery well was at minus 3720. Life decline curves indicate solid, steady production connected to a large reservoir up to the date of simultaneous water drive incursions on 991. This is a detail map on the top of the Sub Clarksville at the Shiner Pond field. Note that the minimum of 85 foot of structural elevation above the 3,700 foot at current oil water contact over a closure area in excess of 300 acres. This is a petrophysical and subsurface data from the Shiner Pond field discovery well. Sub Clarksville sand net pay is 8 foot thick with resistivities of 8 ohm meters and a porosity of 28%. RW used on this is 0.05, yields a water saturation of 24%. The trapping fault is at a depth of minus 3570 with 170 foot of displacement. The life decline curves at the Shiner Pond field. The discovery well, the number 1 drab, commenced production in 1190, flowing at a rate of 96 barrels of oil per day on 20 psi flowing tubing pressure. Cumulative through 393 was 23,875 barrels of oil. Confirmation well, the number 1 Cox, completed 691, was pumping at a rate of 175 barrels of oil per day. Water encroached production on both wells on 991 simultaneously. The number 1 Cox only produced 8 more months to a cumulative of 11,273 barrels of oil before watering out. The flat nature of both the flowing and pumping initial production curves indicate a significant volume to the original reservoir prior to the water drive encroachment. Seismic tie-in to the Graves number 1 drab, the TD and the Pettet. The Graves number 1 drab sonic log was used to tie in on the upthrown side of the regional trapping fault. The Sub Clarksville objective sand interval was faulted at minus 3845 with 170 feet of missing section in the test well as evidenced on the seismic line. The trapping fault was also encountered in the number 1 Hollum test immediately to the north at a subsea depth of 7209 with 400 foot of displacement in the upper Rodessa Bacon member within the anhydrite. This is the red fault plane map. Fault plane map of a regional trapping fault from McCrary Field to Shiner Pond Field and intersection with the Triple Point Junction. This is a montage structure map on the top of the Rodessa, showing adjacent on-trend production from the Pittsburg Sand at Newsom Pittsburg Field to the east, along the production to the west from the Rodessa, McCrary, and Winsboro Fields. Position of the Triple Point spreading junction is shown in green, with the failed arm showing trending north-northeast as a strike-slip transpressional fault. The positive arms of the spreading center, trending 120 degrees west-southwest and east-southeast, are setting up the structure along the regional Salt Ridge roller and the basement spreading with the Sabine platform to the east. The salt roller and trapping fault are shown in the north-south seismic line in the inset. This is our first look, once again, our exploration methodology, showing the closure at the Rodessa level. This is the Rodessa Pettet structural cross-section. This line of section traverses the upthrown side of the closure from deepest at the drab test to the production test at the Benton, to the highest point of closure at the Hollum test, to the downthrown side of the fault at the Evers log. Log analysis shows the upthrown gloid at the Benton and Hollum test to have good reservoir conditions with porosities ranging from 9 to 18% and water saturation from 18 to 33%. Well within the realm of production. There is no cement across the production test at the Benton, as casing was set in the Cotton Valley 2,000 foot deeper, but oil was tested from the free pipe interval in the gloid. The Pittsburg Sand also showed productive log characteristics with porosities ranging from 10 to 15% and water saturations from 38 to 52% over a 20-foot interval. Structural advantage of over 100 foot above this is easily demonstrated, allowing for at least a dozen locations. This is a composite log of the Grace number 1 Benton. Production tested oil from the gloid with porosities of 9 to 18% with water saturations of 18 to 33%. Pittsburg Sand with 10 to 15% porosity and water saturations of 38 to 52% over a 36-foot net interval. This is the surface geology on a topo sheet. Significant production on both sides of the Triple Point Junction is associated with a terrace anomaly of the Reclaw Formation, capping the Carrizo Sand. Prospect area demonstrates a large similar terrace feature. Dominant north drainage is coincident with the failed arm of the Allocogen and also associated with a mapped surface fault trending north-northwest to south-southeast that is manifest as a relief transform fault 60 degrees off the failed arm. This is the surface topography and drainage direction. Large drainage anomaly is evidenced with 12 miles to the north counter-regional drainage trends associated with the Triple Point Junction. This is a diagrammatic model of a Triple Point Junction. This is a discussion on the significance of Triple Point Junction mechanisms worldwide and more particularly at our local condition at the Chalybeate Field. The following are clay cake models of strike-slip fault associated with failed arms and the subsequent pop-up structures that are manifest from this. This is a dough model of a transtensional strike-slip fault, as this fault is put in motion on the model of the overlying dough that is being used to model stratigraphy. This would be the basement strike-slip, laying in of the Jurassic carbonates and salt, subsequent transpression starting to bulge into a small structure, eventually to a very significant structure that fits the structural pattern of these sorts of accumulations along all the local East Texas Embayment rivers. This is our land map. Our current acreage position is 837 acres net with a plus or minus 975 acres gross. Aerial view of the prospect showing the roads and land usage along with the reservoir outline superimposed. This shows the potential reserves, depth, drainage, and objectives indicating a potential recovery of over 4.5 million barrels from 28 wells. This is a total project cost analysis for those 28 wells over 2 years for $15.7 million. The economics might be best demonstrated by finding lifting costs for overall prospect development would be less than $4.50 a barrel of oil. Using $50 per barrel average over a 7-year flush, production starting at 100 barrels of oil per day yields a 6-month payout with a 12-to-1 return on investment. This is the trade. Acreage is being sold at $300 per net mineral acre, delivering an 80% NRI. There is a 20%, 1/5 carry on the first 2 wells, one shallow to 4,400 foot and the other to 8,800 foot on a turnkey basis. The deeper well includes 2 60-foot cores. All development will be on a heads-up basis.